Okay, welcome to part 2 of the basic structural simulation tutorial using Ansys Discovery. In part 1, we ran a quick GPU-powered real-time simulation where we identified where the stress hotspots are, and we made a simple geometry change to try to reduce that max stress, as you can see in this chart. Okay, let's dismiss this. Now what we want to do is we want to get precise results of stress in this area that you see indicated by my cursor. And we want to use the high fidelity Ansys flagship solvers for this purpose. To do that, click here to switch to Analyse Mode. In Analyse Mode, we are using CPU-based Ansys solvers, and we have access to more physics and more controls, as you can see on the top in the ribbon, to allow you to get that precise answer to perform design verification. You'll notice that all my physics inputs carry over from the previous simulation. Okay, so all I need to do in this case is select this face and apply a local fidelity control, also known as a local mesh control. So in this case, I want to apply a mesh of, let's say, 0.5 millimeters. So I can just type in the number 0.5 and mm and hit enter. And you see this additional control shows up on the physics tree. Okay, and that's pretty much all I have to do. And now I can click solve, and this launches the Ansys mechanical solver in the background, and you can see the green progress bar showing up on the SID. Now, I want to remind you that in Analyze mode, we are using our CPU solvers, and we are shooting for much higher fidelity, higher accuracy, and higher level of physics. So this naturally takes a little bit longer, but it's a good time for you to go grab a cup of coffee or a cup of tea. And when you come back in a few minutes, you'll have your high fidelity solutions. So depending on your computer, this should take 2 or 3 minutes. So let's pause for a second and come back when the solution is closer to being done. Okay, you can see the green progress bar is almost all the way around the SID, which means that we're pretty close to being done. So in about a minute or so, it will complete the solution, calculate all the results, and we'll be able to post-process. Okay, you see the simulation results preview showing up. You have a message on the bottom, which indicates that additional results are being computed, just asking you to hang on a little bit. So let's just give that an additional second. But we can manipulate the model, zoom in, and things like that while it's finishing the computation of results. You'll notice that as I hover my mouse over the results, there is a number on the legend on the right which updates, which indicates the exact value in the location where my cursor is currently hovering over. So this is a handy way to get precise information on local areas of interest. Okay, there we are, we're done. Now I can see my high stress area, which I had before, but I can also overlay the mesh by clicking on this button. And you see, of course, that I have a very, very fine mesh in this area. So this is the benefit of the Analyze mode. It allows you to get a much more high fidelity, high accuracy result by focusing your attention and efforts on areas of interest, in this case by applying a local mesh control. I'd like to point out that you can change the scale for the legend by simply grabbing the line on top and dragging down. You see that? You can click this icon to turn off the clip to range. So if I do this, you see how the areas which exceed the stress value I've indicated show up in this kind of pink color. I can also type in that value manually. So let's say I want to have my maximum value for stress capped off at 8 e to the 7. And there we go. It shows you exactly where this is. So let's pretend that this value is the yield strength of this material. So any area which has that particular color is an area of concern. You'll also notice that if I click on the chart, we have a purple dot or a purple triangle, which indicates the result that I got from the Analyze high fidelity solution. It's not so far off from my GPU-powered calculation, but it's a nice way to compare results and so on. I could perform, for example, a mesh dependency study by changing the fidelity setting and see how that impacts my solution, which is a common thing that people do when running this type of simulation. So there you have it. This is the end of part 2. We walked you through a simple structural simulation. One thing before I leave, I want to point out that if you want to hand over these results to a colleague who is using our Ansys Mechanical Expert Level tool, you can do that by clicking here and saving a file that he or she can export or import into Ansys Mechanical. Okay, well, that's it for this tutorial. We hope you enjoyed it, and we hope you'll take a look at the other tutorials in this series. Thank you very much.